안녕하세요. 저는 서울대학교 Otto van Koert입니다. Welcome, I'm Otto van Koert from the Mathematics Department of Seoul National University. This course will be about big data mathematics. The point of this course is to give you the necessary mathematical ingredients to work and understand big data. Most math curricula focus on the mathematical aspects only. Some of these are useful for big data, some of these aspects are less useful. In this course, we focus on those parts of mathematics that are relevant for big data. These topics include vectors for storing and manipulating big data, matrices and tensors with the same goal, but with an addition will be used to transform data, but also tools like Fourier analysis, which is more advanced, but very useful to understand time series. In particular, it helps us to see what frequencies are present in a signal. We also learn about derivatives, which are important for optimization, the least squares method, and some aspects of probability theory. So to give you a better indication about the composition of this lecture, the lecture starts with vectors and matrices, because these are important storage tools for big data. That's the beginning of the lecture. Then, in the middle, we look at some tools of calculus. These tools are necessary to define the derivative, which is the slope or rate of change. And this is important to both work with and understand and analyze data, but also to minimize errors in the least squares method or to optimize neural networks. So that's the middle part of the lecture. After that, the third quarter will be about the least squares method. This is a particular method to fit data. And finally, we look at some elements of probability theory. Along the way, we also look at models coming from differential equations. These use the rate of change to model data. The criteria for successfully completing the course are as follows. First of all, there are two exams. There's a midterm exam and a final exam. These are somewhat of a traditional nature. In order to prepare you for these, there are short quizzes. And in order to make the course more practical, there is some project-based learning, so-called PBLs. There will be projects about stock markets, about disease models, and about optimizing portfolio. These will use the computer to make the topics more lively. We will also do that throughout the course and give some Python-based examples. The main criteria are hence 2 exams, 4 quizzes, and a couple of PBL projects. As for advice, when it comes to this class, I recommend to take many lectures, to see the course, to sample what tools are available for mathematics. You will learn many concepts, and it's good to practice a bit, play around with actual data to make these concepts concrete. What really matters is to just listen and be exposed to new material. So in short, 강의 들으면 많이 도움됩니다. 많이 들어주세요.